Today in this class we will be dealing with the architecture of SIC machine as well as its programming concepts. So when we have dealt with SIC machine, we were dealing with memory, registers, instruction types, addressing modes, etc. we have studied. Similarly, in this also we need to know about the memory, registers, etc. So we are starting with memory. In case of SIC machine architecture, it will be having a maximum size of 2 raised to 20 bytes, which is also equal to 1 megabyte. Where in case of SIC, we were having 2 raised to 15 bytes. Similarly, there is some change in the instruction formats and addressing modes in case of SIC Xe architecture. In case of registers, in addition to the registers that is used in the SIC, in SIC Xe, it makes use of some registers like B, S, T, F, represented using the numbers 3, 4, 5, 6 respectively, where the B register denotes the base register, S and T, they are considered as a general working register with no specific use, and F will be considered as the floating point register, which is consisting of 48 bits. The rest will be able to store 24 bits. An example for the instructions that is used in SIC Xe is given: add R, COMP. So in SIC you were having add and COMP. Here an additional R letter is appended together with the instruction, which indicates that the operand will be having 2 registers. Since it is having 2 registers, the instruction opcode will be specified using the letter R. So add R. The result will be like what the instruction shows is A is equal to A plus S. Addition operation will be performed. The result will be stored in the second register A. Then related to data format, it is having in case of 48-bit floating point data type, it is having a sign bit 1, exponent field 11, fraction field 36 bits. So sign bit in order to represent plus and minus, where 0 will be used to represent plus and 1 for minus. The fraction F will be taking a value between 0 and 1, and in case of exponent E, it will be an unsigned binary number between 0 and 2047. So in the magnitude value can be computed as S into F into 2 raised to E minus 1024. This is the maximum magnitude value of the value stored in the register. In case of instruction formats, as we have said, we are having 2 raised to 20 bytes of memory in SIC Xe. So we can make use of four types of instructions. We all know that instructions will be having an opcode field and address field. So here we can in SIC Xe it supports 4 types of instruction: format 1, format 2, format 3 and format 4. So the 1 byte instruction will be like an opcode alone, 2 byte instruction will be an opcode with some register R1 and R2, and 3 byte will be like it will be having an opcode and some bits used for representing the target address in the form with the help of the addressing modes, and displacement field in order to compute the target address. So NIX BPE, these bits it helps in identifying the addressing mode so that the target address can be calculated in a proper way. And the 4 byte instruction, it will be having 4 byte instruction will be having opcode field and NIX BPE, those bits. In addition to that, it will be having an address field of 20 bits. Okay, 20-bit address field will be there. That is the main difference. And in order to distinguish between format 3 and format 4, we make use of the variable E, bit E. And if the E bit is equal to 0, it means that it is format 3, and if E bit is equal to 1, it is format 4. Now coming to the addressing modes, in case of SIC machine architecture, we were having only 2 addressing modes in case of SIC machine architecture, that is direct and indexed. But here we are having more number of addressing modes, starting with base relative and program counter relative. In that we will be considering the bits B and P. So in bits B and P, if B is equal to 1, it is base relative. Target address will be computed as TA is equal to B plus displacement, and where the displacement value will be between 0 and 4095. In case of program counter relative, B is equal to 0, P is equal to 1. Target address will be equal to, here a mistake is there, TA is equal to PC plus displacement. So correct it. In place of B, you need to make it as PC in case of program counter relative. And displacement value, you can take the value ranging from -2048 to 2047. So in case of base relative, displacement will be a 12-bit unsigned integer, and in case of program counter relative, it will be having a 12-bit signed integer. That is one more difference between base relative and program counter relative. And if the B and P value, if it is equal to 0, then it indicates a direct addressing integers, which means the displacement field or the address field, it is having the target address. And if x is equal to 1, some index addressing is given. That is it denotes the index addressing. Some other value will be stored in the index register that we need to compute in the target address calculation. And coming to the immediate addressing mode and indirect addressing mode. Immediate and indirect addressing mode, we will be making use of the variables I and n. If I equal to 1, it means that immediate addressing mode. If n equal to 1, it is indirect addressing mode. And if both I and n equal to 0 or 1, then it is considered as a simple addressing. And the target address also is calculated in the similar way. Immediate addressing mode, no memory reference will be there. Target address will be there in the operand itself. Indirect addressing modes, you will be getting a target address, and the actual address will be obtained from the target address. So target address you will be getting from the target address. You will be getting an address to get the operand value. And I equal to 0, n equal to 0 indicates the standard SIC. I equal to 1 and n equal to 1. It indicates target address can be computed as the address of the operand value. So we can learn or understand this with the help of an example. So in this you are having memory. Memory is stored. Memory is there, in which some values is stored in the memory addresses. These are considered to be as the memory addresses. So we are initializing some values, assuming some value as base register is having 6000, PC is having a 3000, and X is having 90. So base register, PC, and index register. So considering the first example, here we are not giving any opcode here. So it is given as 0. So opcode is, we are not considering any opcode here, just consider this NIX DPE value and determine the addresses. Target address and how it is being fetched from, how the value is fetched from the memory. So first case is like n equal to 1, I equal to 1, which means that it is a symbol addressing mode. In case of symbol addressing mode, what do you need to do? You will be getting some displacement address. You will be getting some displacement or address from the operand field. Now here one more thing it is given, that is p is equal to 1, which means that some value you will be getting from the address field which need to be added with this PC. Okay, so what is the value obtained from this displacement field? So this is 6, and here 0, 0. So with this 3000 you need to add 600. So you will be getting the result as 3600. Okay, 3600. Now next is like you will be getting one address from the memory 3600. It will be having some value, and that value will be stored here. That value will be retrieved and stored in the target location. Next case is like n equal to 1, I equal to 1, x is equal to 1, which means you need to make use of the X register 0. X register is having a value 090. Okay, this X register is having a value 090. Then base relative b is equal to 1, which means you need to consider this value 6000. Okay. Next you are considering the displacement or address field. What it is given? This will be 3 and 0 0. So 3 0 0. So when performing the addition, you will be getting the result as 6 3 9 0. Okay, 6390. You are getting the result. So from the memory, in the 6390 location, you are getting the value 00C303, which will be stored into the required register. Okay, so this is the case with the, all these examples. We consider the third one, n equal to 1 and p is equal to 1. So here one more thing you need to check. All these e bits, it is set to 0, which means these instructions, they are following format 3. The last two instructions, they are following format 4. Okay. So n is equal to 1, p is equal to 1. Similar, you will be getting the value 0 3 0 as the displacement address. 0 3 0 0 3 0. Then it is PC relative. PC value is 3000. PC value is 3000. So totaling it, what you will be getting? 3030. That is the address. Now the addressing mode is n equal to 1. N equal to 1 means what does that mean? Indirect addressing mode. So 3030, you will be getting one value which will be some address where the actual value is stored. In these three cases, from the memory directly you got the value. In this case, in these two cases. In the third case, what you have to do, 3030 will be having some address, that is 3600, where the actual value is being stored. Okay, 3030, that is the target address you have computed based on the instruction that is given, and you will be getting one address 3030. In that address you will be having one value, that is 3600, which is the address where the actual value is stored. Why? Because n is equal to 1, that is indirect addressing mode is being applied. So the value retrieved from the memory is 103000. Okay, that is the difference between indirect addressing mode and simple addressing mode. Next is related to the immediate addressing mode. So immediate addressing mode means from the operand itself you will be getting the address. Okay, that is the address or the value you will be getting from the operand itself. So 0011, that is 3, this one 0, and here also this one is also 0. So the result is target address is 30. So that one will be treated as the value. Okay, displacement or address field. Since it is a format 3 instruction and it is using an immediate addressing mode, so the operand will be having the actual value, immediate addressing mode. It's not an address, it's a value. Then in case of simple addressing mode and format 4 instruction, it is given as P is equal to 1, which means PC relative addressing mode. In that case, format 4 instruction, we will be getting the addresses 600. Since it is PC relative, what you have to do, 600 will be added with the PC value 3000. So you will be getting the result as 3600. So 3600 is having the value 103000. That will be pursued the target location, placed on the target location. In case of next example, format 4 equal to 1 and simple addressing mode is used. N is equal to 1, I is equal to 1, and here the 20 bit field is filled with the memory, filled with some value that will be the address. No PC is not enabled, base is not enabled, nothing is enabled, which means that the address is there in the memory, in the operand itself. So which means 1100 is C and 0011 is 3, 0. Okay, so you will be getting the addresses C303 from the memory. What value will be retrieved from the memory? C303. You will be getting the value as 003030, which is loaded into the memory. So this is the example. You need to understand so that it will be helpful when studying the architectures in detail in the coming modules. So next is we need to learn about the instruction set. So instruction set, we know that different registers are there, so instructions also will be different. Since we are making use of BSTF registers, we are having the instruction LDB, STB. So in case of SIC, we were having LDA, STA. Similarly here, LDB, STB. Those registers additional we have used, so additional instructions also can be inserted. In floating point arithmetic operations, we are using floating point registers. So some instruction like add f, sub f, mul f, div f can also be used. Then here, more than one registers we will be using. Register to register arithmetic operations are allowed. So add r, sub r, mul r, div r. Register move operations to perform, RMO instruction is used. and supervisor call instruction SPC will be used. These are some additional instructions that is used in Sic Xe architecture. Then related to IO instructions, start IO, test IO, hold IO. IO instructions. Purpose is to start, test, halt the IO devices that is used. So there are more some instructions that is given in the end of your textbook. That also, if you want, you can refer for understanding purpose only. Okay. So we can move to the programming examples. In case of programming examples, we will be similar to SIC. We will be having an opcode field and operand field. So in detail, we can study starting from the data moment.